Hello everyone. In this video, we are going to solve the problem number 1.66 from Irodov, and that is related to dynamics. So let us first understand the problem and then we will solve the problem step by step. We are having a small body A which starts sliding from the topmost point, that is O1, to the bottommost point, that is O2, and the length of the base is given as L is equal to 2.1 meter, and the coefficient of friction between the body and the wedge surface is given as K, that is equal to 0.140, and we have to find the angle alpha, for which the time taken for the body to travel from O1 to O2 will be the least one, and we also have to find that particular time. For that, let us draw the free body diagram of the body A. So this is body A, which is placed on this surface, which is making an angle of alpha with the horizontal. So we will have the gravitational force mg in the downward direction and the normal reaction from the wedge surface, and we will have the friction force in this particular direction as it is moving in this direction with the acceleration of, let us say, a. So friction force we can write mu into or k into n because it is in the dynamic condition. Let us take the component of mg in the normal and the tangential direction. Okay. So if this particular angle is alpha, then this angle will be 90 minus alpha and this angle will be alpha. So if this angle is alpha, then this particular component will be mg cos alpha and this component will be mg sin alpha. Now let us balance the force in the normal direction as there is no acceleration in the normal direction. So we can write n is equal to mg cos alpha, and if we write the force equation in the tangential direction, then we can write it as mg sin alpha minus friction force, that is equal to mass into acceleration, and friction force we can write it as k into n, and n we have found out here, that is mg cos alpha. So let us substitute it here. So we will get mg sin alpha minus k times mg cos alpha is equal to mass into acceleration, and from here we can find a is equal to g sin alpha minus kg cos alpha. So this is the expression of acceleration we got, which is the function of alpha. Now let us say while traveling from point O1 to O2, the body A is taking the time of t. So from the equation of motion, we can write it as distance is equal to ut plus half at square, where u is the initial velocity, a is the acceleration, t is the time, and s is the displacement. So in this particular case, initial velocity is equal to 0, so we can write the displacement is equal to half into acceleration we have found out here, that is g sin alpha minus kg cos alpha into t square. Now in this particular triangle of the wedge we have given with L and alpha. So from these two parameters we can find this particular distance. So we can write L divided by S, that is equal to cos alpha. So from here we can write S is equal to L divided by cos alpha. Let us substitute the value of S is equal to L upon cos alpha here. So we will get L divided by cos alpha is equal to half times g sin alpha minus kg cos alpha into t square. So from here we can get t is equal to 2L whole divided by cos alpha g times cos alpha sin alpha minus k times cos square alpha under root. Okay. Now we know sin alpha into cos alpha twice is equal to sin of 2 alpha. So from here we can write sin alpha into cos alpha is equal to sine 2 alpha by 2. Let us substitute the value of sine alpha into cos alpha from here. So we can write time taken is equal to 2L whole divided by g times sine 2 alpha by 2 minus k times cos square alpha under root. Now in the problem it is asked to find the minimum time. For that, if we have to minimize this particular time, for that whatever function we have written which is the function of alpha, that we have to maximize so that the denominator will be maximum, so the overall quantity will be the minimum. So let us maximize sine 2 alpha by 2 minus k times cos square alpha. Let us denote it as f. So we can write df upon d alpha is equal to 0 in order to maximize this particular function. And if we maximize this particular function, that means we are minimizing the time. Okay, so we can write d by d alpha of sine 2 alpha by 2 minus k times cos square alpha. Differentiation of sine 2 alpha is cos 2 alpha, and the differentiation of 2 alpha is 2, so we can write 2 times cos of 2 alpha by 2 minus k times differentiation of cos square alpha is 2 cos alpha into minus sine alpha is equal to 0. So from here we can get cos 2 alpha plus k times sine 2 alpha, because 2 times sine alpha cos alpha is sine 2 alpha, that is equal to 0. So from here we can find tan of 2 alpha is equal to minus 1 upon k. Okay, and how do we know that this is the value we got alpha, that is maximize this particular function? For that, let us find out the derivative of df upon d alpha. So we can write d by d alpha of df upon d alpha, that is equal to d by d alpha of df upon d alpha that we have found out here, that is cos 2 alpha plus k times sine of 2 alpha. So from here we can get minus 2 times sine of 2 alpha plus 2 times k into cos of 2 alpha. Now let us substitute the value of k here. So we can write tan of 2 alpha is equal to minus 1 divided by 0.140, and if we evaluate this one, then we will get 2 alpha is equal to 98 degree or alpha is equal to 49 degree. Okay, and if we substitute the value of 2 alpha is equal to 90 degree here, sine 2 alpha will be positive and cos 2 alpha will be negative. If sine 2 alpha is positive, that means this particular quantity is negative and this particular quantity is also negative. That means d square f upon d alpha square is negative. If the second derivative is negative, that means we are finding the maximum value of f. And if we are finding the maximum value of f, that means we are minimizing the time. Now we have obtained the value of alpha, that is 49 degree, and if we substitute the value of alpha, L and G and K in this particular expression, then we will get that time is equal to T minimum is equal to 1 second. Okay, so this is the minimum time it will take for alpha is equal to 49 degree. So I hope the entire procedure is clear. Thank you.